Hi everyone, this is Katie. Today's topic is exponent rules. I'm going to go over the rules with examples. So let's start with the product rule. So we've got x cubed times x to the power of 8. So when you're multiplying powers, you're adding the exponents. So 3 plus 8, which is x to the power of 11. So that is called a product rule. X to the m times x to the n is x to the m plus n. Let's try a few more examples. So let's say 2 to the power of 4 times 2 to the power of 2. Make sure you check the bases are the same. If the number underneath the exponents, if those numbers are not the same, then we can't apply the product rule. So that will be 2 to the power of 4 plus 2, which is 2 to the power of 6. Let's try another one. X squared times y. When you have a bracket and there's no operations between, that means it's multiplying. X cubed y to the power of 4. Okay, these are all multiplication. That means we're going to add the exponents to the same basis. So x and x, so exponents 2 and 3 will be added. And here's no exponent written, but that means it's the exponent 1. So 1 and 4 will be added. So x to the power of 2 plus 3 and y to the power of 1 plus 4. So that is x to the power of 5 times y to the power of 5. Let's move on to the next rule. Next one is called Quotient Rule. Quotient means it's a dividing or division or fraction. So here's an example. X to the power of 5 over x squared. So once again, the bases must be the same number or same symbols to apply the quotient rule. So when you have the fraction form like this, we're going to subtract. In subtraction, the order does matter, so that means we have to use the same rule. For example, this one, 5 is on the top in the numerator and 2 is in the denominator. The subtraction, the order that we're taking is from top exponent minus the bottom exponent. So it will be x to the power of 5 minus 2. So make sure you follow the same order for quotient rule. So it is x to the power of 3. So if you write that rule, it will be x to the power of m over x to the power of n. Which means x to the power of m minus n. So here are some more examples using quotient rules. Quotient rule. 3 to the power of 5 over 3 to the power of 3. Following the rule, 3 to the power of 5 minus 3, which is 3 squared. How about this one? We have two bases. We have x with the exponents 2 and 1. And we have 5 and 3 for the very base as the y. This one will be x to the power of 2 minus 1. So top, make sure you subtract top exponent minus bottom exponent. Y to the power of 5 minus 3, which is x to the power of 1 You can write the exponent as 1, or you can just leave it as blank and write it as just the x and y squared. Third rule is called zero exponent rule. So this rule is for the exponent 0. So for any base except 0 is raised or with the exponent 0, the power is always 1, where x is not equal to 0. So a few examples, maybe y to the power of 0 is 1 when y is not equal to 0. Another example, 6 to the power of 0 is always 1, and maybe 7a cubed b to the power of 100. So no matter what you have as the base, as long as the exponent is 0, then it is the whole value is 1. So that's called the zero exponent rule. Next one is called the power rule. The power rule is like this. X cubed is called power. This is a power. And that power is raised by another exponent, say square. When that happens, we're multiplying the exponents together to simplify. So it will be x to the power of 6. So here's the rule. X to the power of m raised by another exponent n. Then it will be x to the power of m times n. Say 3 squared to the power of 4 is 3 to the power of 2 times 4, 3 to the power of 8. Let's try another one. Y to the power of 5 squared, and will be y to the power of 5 times 2, which is y to the power of 10. Next rule is called power of product. So when you have a base as a product, for example 2a, and that is raised by another exponent, say 3, then this exponent outside the parent brackets, it will be distributed to each factor inside the bracket or product. So the 2 will take this 3 as the exponent, 2 to the power of 3, and a will also take the exponent 3, so which means a cubed. So 2 to the power of 3, 3 cubed, 2 cubed is 8, and you can write it as a cubed in short form. If we write that rule down, then it will be a to the power of x, b to the power of y, raised by another exponent m. It will be a to the power of x m, b to the power of y m. Let's try another example using the power of a product. 6x cubed squared. The square goes to the 6, and 2 squared goes to x cubed. So 6 squared times x cubed squared will be 36, and x cubed to the power of 2 is power rule that we're going to use. It will be x 3 times 2, which is 36 x to the power of 6. There is also power of a quotient rule. If you have a quotient as the base, x squared over y, and raised by another exponent, for example 4, this outside exponent goes to the numerator and denominator. So it will be x squared raised by exponent 4, denominator y to the power of 4. Using the power of power rule, the numerator will be x to the power of 2 times 4 and simplified as x to the power of 8 over y to the power of 4. So here's the rule for power of a quotient. X over y to the power of m is x to the power of m over y to the power of m. Let's try another example. Applying the power of quotient rule. 2x over 3y squared and raised by exponent 3. So 2x raised by power of 3y squared raised by the same exponent 3. So this is the product. This is the power of product. So will be applied to each factor inside the brackets. It will be 2 cube x cube, another power of product in the denominator. 3, the exponent 3 goes to the 3, and that goes to the y squared. It will be 3 cube y squared to the power of 3. So 2 cube is 8, x cube, 3 cube is 27, and this part is the power of power rule. So it will be y 2 times 3, which is y to the power of 6. And that is the answer for the last example. Okay, we're left with the one last rule for the exponent laws, and that is for negative exponents. So what happens if you have exponent as a negative integer? If a factor in the numerator or denominator is moved across the fraction bar, the sign of the exponent is changed. Okay, so that's the definition of the law, or that's a definition of that negative exponent. But let's do some examples. So let's say you have x to the power of negative 2. If that happens, this negative exponent will take the reciprocal of the given base. The reciprocal means you are flipping the numerator and denominator. So let's say reciprocal of 2 is 1 over 2. And reciprocal of 1 over 3 is 3 over 1, which is 3. Reciprocal of 2 over 3 is 3 over 2. So you are given with x as the base. The reciprocal of the x is 1 over x. And that is from the negative sign. And once the negative sign flips the base to the reciprocal, we're going to keep the exponent as positive form. Like this. And if you simplify that, that will be 1 over x squared. Let's try another example. Say 4 to the power of negative 2. So this negative sign will change the base as the reciprocal of the 4, which is 1 over 4. And negative is gone now, and the new exponent is just the positive 2. And that is same as 1 over 16. Maybe we can do quotient base. So let's say x squared over y to the power of negative 3. This will be used, the negative sign will be used to flip the numerator and denominator. So these will be flipped. So y is on the top, then in the numerator, and x squared will be on the denominator. And now the new exponent is 3. Once you have that, we can apply the other rules. So in this case, it will be power of a quotient. So 3 goes to the numerator and 3 goes to the denominator as the new exponent. So y cubed over x squared to the power of 3. And that is y cubed over x to the power of 2 times 3, that's 6. Let's do one more. This one, negative 2 x squared y to the power of negative 4 to the power of negative 2. This one, we are not going to flip the base in this case because the base is a bit long. So we're going to apply the power of a product rule first, even though we have a negative exponent. So that goes to every single factor inside the brackets. So there are 3 factors. We're going to apply negative 2 as the exponents. So negative 2 to the power of negative 2, x squared to the power of negative 2, y to the power of negative 4 to the negative 2. So this one, now we can apply the negative exponent to take the reciprocal. So negative 2 is the base. If you take the reciprocal, it will be negative 1 over 2. And that will be taken as positive 2 as a new exponent. And this is power of power rule. So it will be x to the power of 2 times negative 2. This is another power of power rule. Y to the power of negative 4 times negative 2. If you take the negative 1 over 2 to the power of 2, that will be 1 over 4. Because we're taking square of a negative, even though there's a negative sign as the base, it will be positive at the end. Okay, and x to the power of negative 4, y to the power of positive 8. Okay, since we don't like to have a negative exponent at the answer, in the end, the final answer, we're going to change the form to get the positive exponent. So this will be simplified as 1 over 4 times 1 over x to the power of 4, y to the power of 8. So these are fractions. We can combine those two. So 1 over 4 times 1 over x to the power of 8. And if we change that to fraction form, we can also write it as y to the power of 8 over 1. And these are all multiplications, so we can combine that whole thing in one fraction. So 1 times y to the power of 8, that's just y to the power of 8. And the denominator is just the 4x to the power of 4. And that's it. So that's the answer for the last example. And note or caution. So when you have a negative x, this is not same as 1 over x. X to the power of 1 is same as 1 over x. Just make sure you, we're looking for the negative exponent, not the negative number in front of, negative sign in front of the x when you're taking the reciprocal. Also, when you have negative 3 to the power of 2 or negative 3 squared, means you're multiplying the whole base, whole number, negative 3 twice. It's not same as negative 3 squared. So you have to make sure you know what the difference between negative 3 squared and negative 3 squared. So this is you're multiplying negative 3 as the base, and this one means negative 3 times 3, which is negative 9, but the above one is positive 9. So an exponent applies to only the factor it is directly next to, unless there are brackets enclosing the other factors. So in this case, there is brackets around negative 3. That's why we're multiplying negative 3 2 times. But this one doesn't have a bracket, or this doesn't apply. This negative sign is not attached to the base, which is 3. So that's why we're multiplying 3 2 times, not negative 3 2 times. That's it for today, and thanks for watching, and see you next time.